Hello dear friends, welcome to the fifth video on assignment problem. In this video we will study the traveling salesman problem under assignment problem. After watching this video you will be able to understand the concept of traveling salesman problem. You will be able to differentiate between the normal assignment problem and a traveling salesman problem, and you will be able to solve numericals based on the traveling salesman problem. The traveling salesman problem consists of a salesman and a set of cities. The salesman has to visit each one of the cities, and he has to start from a certain point, and he also has to return back to that particular starting point after visiting all the cities. This is the first constraint for traveling salesman problem. The second condition is that he cannot skip any city. He has to visit each city at least once, and he cannot visit to any city more than one. Okay, so why we study the challenge, or why we study the traveling salesman problem? Okay, the challenge or the aim of studying of TSP is that the traveling salesman always tries to minimize the total length or the traveling cost of his trip. Okay, now what is the difference between the normal assignment problem and a TSP? A normal assignment problem always try to optimize the total cost of or the effectiveness of doing all the objects. Okay, but a TSP deals with finding the shortest route in an n city situation where each city is visited exactly once. Okay, also please remember that visiting from city I to I is not permitted. Okay, now let us understand the representation of a TSP using a simple method. Now this is the representation of a TSP problem. As I have mentioned earlier, that visiting from A to A, B to B, C to C, D to D, that is from a particular city to that particular city, is not permitted. So infinite values has been assigned under these particular cells. Okay, now these other cells are the cost elements, and they can represent the distance, time or cost between pair of cities. Also please note that in case of an assignment problem these two things are different, but here these two both are the cities, that is A, B, C and D. Okay, now how can we solve a TSP problem? There are two phases for solution of a TSP problem. Okay, now the first phase consists of a solution of the TSP problem using the Hungarian method, and the manner of this solution is similar to that of the normal assignment problem. Okay, then after finding the optimal assignment using Hungarian method, we have to check the condition for optimality of TSP. That is, we have to check the two condition. The first condition is that whether all the cities has been covered, and the second condition is that whether the starting point and the ending point of the trip of the salesman are same. If the assignment is optimal and these two conditions are met, then we can say that this is an optimal assignment or optimal TSP solution using phase 1 or using Hungarian method. Then we have to finish that question there, and we have reached to an optimal solution. But if any of the condition for TSP or both of the condition of TSP has not been met, then we have to move to the phase. In phase 2 we will find the solution of TSP using any of the three methods, that is by making adjustment in solution using inspection, by forming a single circuit, or by branch and bound solution. In this video we will use the phase 2 standard and find the TSP optimal solution using adjustment in the solution by inspection. Okay, so let us have a look on the simple example and try to solve this. Now this is the example. In this example, 5 cities has been given, A, B, C, D, to which the salesman has to visit. Okay, the constraints are same, that he can start from a particular point and has to revert back to that point after visiting all the cities at least once. Okay, so from A to A, B to B, and similarly from E to E, the visit is not permitted and they have been marked with the infinity. Okay, and these are the traveling cost. Okay, so this we have to find the minimum route cost. Okay, now we can say that this is a TSP problem to minimize the traveling cost. Now we will solve this question initially with the help of Hungarian method, and then we'll move to the phase 2 to find the optimal TSP solution. Now we know that in phase 1 we have to solve the TSP problem using Hungarian method. So in case of an Hungarian method, we have to generate an opportunity cost matrix, and for that purpose we have to follow the two operations. First operation is the row reduction and the second operation is the column reduction. So let us start with first operation of row reduction. Okay, now let us select the row 1, and in row 1 we have to select the minimum element. So here this 2 is the minimum element, and then we have to subtract this 2 from all these values. This value will remain unaffected. Okay, now after subtracting this 2 from these all values, we will be having a new row, that is infinity, 2, 8, 12 and 0. Okay, now moving to row 2, you will see that 4 is the minimum element. Then we will subtract this 4 from all these elements. So after subtracting this 4 from all these elements, we will be having 8, infinity, 2, 6 and 0. In row 3 or row C, you will see that 8 is the minimum element. We have to choose it, and then we have to subtract this 8 from all these elements. So after subtracting this 8 from all these elements, we will be having 8, 6, infinity, 0 and 6. Similarly here 8 is minimum element, so if you will subtract this 8 from all these elements, you will have 16, 0, 4, infinity and 2. And in row E, 2 is the minimum element, and if we will subtract this 2 from all these elements, we will be having 0, 4, 2, 12 and infinity. Now we have to perform the column reduction operation. So before performing the column reduction operation, please check if all the columns are having zeros or not. Okay, if all the columns have zeros, then you need not to perform the operation of column reduction. Okay, and the reduced matrix is a opportunity cost matrix. So let us check for zeros in all columns. Now here a single 0 is available. In column B, 0 is available. Here in column C, no 0 is available. So this column is not having a 0, so we have to perform the operation of column reduction. Okay, so we are going to perform now the operation of column reduction. Okay, in the column 1, you will see that 0 is the minimum cost element. So if you will subtract 0 from all these elements, there will be no effect on these values. So we can write these all values as it is in this column reduction matrix. So infinity, 8, 8, 16 and 0 are the elements. Again in column B, you will see that 0 is available, so there will be no change if you will subtract this 0 from all these elements. So we can write this column as it is here. Okay, now in this case you will see that 2 is the minimum cost element in this column, and it is occurring at 2 times. So we can choose any of the 2 randomly. Okay, so let us choose this 2 and then subtract this 2 from all these elements. Okay, so if subtracting this 2 from it, we will be having 6. Then if you will subtract, now if you will subtract this 2 from 2 itself, you will be having 0. Infinity will remain as it is. Subtracting 2 from this 4, we will be having 0. No, sorry, 2, and subtracting 2 from 2 itself, we will be having 0. Okay, now in these 2 columns D and E, zeros are the minimum cost elements, so they will not be affected after subtracting 0. So these two columns will remain as it is. So this is the opportunity cost matrix. Okay, now we have to make assignment in this opportunity cost matrix. So let us make assignment here. Okay, so for making an assignment, first of all you have to start with row 1. Okay, now in this row you will see that the single 0 is available and we can make an assignment to this 0. So let us make an assignment to this cell, and then we have to check the column for zeros. Now there is a 0 available here, so we have to cross this 0. Now moving to row 2, you will see that there is a single 0 available here. Okay, so we can make an assignment to this 0. Okay, now after making assignment to this 0, we have to check this column also, and you see that there is a single 0 available here apart from this assignment, so we have to cross this 0. Okay, now moving to row C, you will see that there is a single 0 and it can be assigned. So let us make an assignment here. Then we have to check this column. As no zeros are available, we can move to the row D. Now you will see that there is a single 0 available, so let us cross, or let us make an assignment to this 0. Okay, then we have to check this column. Okay, as no 0 is available in this column, we have to move to row E. Now you will see that there is a single 0 in row E, so we can make an assignment to this cell. Okay, now after making this an assignment to this cell, you will see that all rows or all zeros are either being assigned or crossed out, so we can move for next step, that is for checking optimality for made assignments. Okay, now you will see that here the number of assignments made are 1, 2, 3, 4 and 5, and the number of rows and columns are also 5. So this is an optimal assignment. Okay, from the assignment problem point of view, this is an optimal assignment and we can have an optimal cost. But in case of traveling salesman problem, we have to check two more conditions. The first condition is that whether the starting and the ending point of the traveling salesmen are same. Now in this case you will see that he has started from A and then moved to E, and then from E he has returned back to A. Now here you will see that the starting and ending point are same, so the first condition has been met. Now in second condition you have to check that whether he has visited to all cities or not. Now you will see that he has visited from A to E and then returned back from E to A. Okay, this means that he has not visited to B, C or D cities, means he has violated the rules of TSP by not visiting the cities B, C and D. So the assignment made is optimal from the assignment problem of point of view, but from the TSP point of view this is not an optimal assignment and we have to move to phase 2. Now in phase 2 solution will be adjusted by inspection. Okay, but before making an adjustment in solution we have to consider certain conditions for making adjustment. 2. Now in revised assignment, first of all we have to make an assignment to the next lowest cost element from the matrix. Okay, for example here you will see that initially we have made an assignment to this 0. Now we have to make an assignment apart from that 0, and for that purpose you have to select in first case the 0 available, okay, the 0 which is apart from this 0, okay, as initial in assignment has been made to this 0, okay. Now if apart from this 0 no 0 is available, you have to choose the minimum cost element, okay. For example, you can choose 1 or 2 if available. In this case you will see that 2 is available, so we can choose that, okay. Now if in certain cases, if apart from 0, 1 or 2 no smaller element is available, you can choose any other higher value, okay. So let us make an revised adjustment of assignment in this table, okay. So here you will see that this 0 has been assigned in previous assignment, and that will lead to an unoptimal solution. So we will not make an assignment to this 0, okay. Now apart from this 0 no 0 is available, so we have to choose any smaller cost element. So in this row you will see that this 2 is the smaller element, okay. So we are now making assignment to this particular element, okay. So let us make an assignment here, okay. Now after making an assignment here, we have to cross the 0 available in this row and also in this column, okay. Now the 0 is here, so we have to cross it, okay. Now as assignment has been made in row A, we have to move to row B. Now in this case you have seen that in row B the already an assignment has been made to this 0, so let us again make an assignment here and then check for the zeros in this row, okay. Now a 0 is available in this row, and also we have to check the column, okay. Now in this case you will see that a 0 is available, so we have to cross this. Also an important thing is that as 2 has been chosen as the least cost element in row 1, so we have to cross this 2 also, okay, as this has been chosen for making an assignment. So let us cross this 2 also, okay. Now moving to row 3, you will see that there is a single 0 available here, so we can make an assignment to this 0. So let us make an assignment to this 0, and then we have to check this row and this column for other zeros, okay. So no other 0 is available, we can move to the row D. Now in this row you will see that this 0 and 2 has been cancelled, so no 0 is available, okay. So we have to make an assignment to lower cost element, and in this row you will see that again 2 is the minimum cost element, so we can make an assignment to this cell, okay. So this has been assigned. Now again we have to check for any 0 in this column, okay. Now we have to move to row 5. In row 5 you will see that there is a 0 available, so we can make an assignment to this 0, okay. And then we have to check this column also, okay. After checking all these values, we have seen that all zeros has been crossed out or been assigned, or all the rows or the columns has been assigned, okay, with a particular cell. Now we will check for the route and the number of cities visited, so that we can check whether it is an optimal solution for TSP or not. Now in this assigned matrix you will see that the salesman started from A and visited to B. So first step is moving from A to B, okay. Now after B he has visited to C. From B he has visited to C, because this is the assignment. So from B to C we have marked a movement, okay. Now after from C he has moved to D, as this cell has been assigned. So from C to D we have again marked a route, okay. Now from D he has moved to E, as DE cell has been assigned. So this has also been marked with an arrow as a route, okay. Now from E he has moved to A, as EA cell has been assigned, okay. Now EA cell has been assigned, okay. Now you will see that the starting and the ending point are same. So first condition for TSP has been met. Now we have to check whether all cities has been visited or not. Now you will see that he has visited to A, B, C, D and E, and these are only the 5 cities. So the second condition, that is all cities has been visited, is also satisfied. So both the constraints for TSP has been met. So this is an optimal solution, okay, for this TSP problem. Now we will find the transportation or the traveling cost. Now if you will consider this assignment and will find the cost from initial matrix, we can find the total minimum cost. So if you will have a look in this initial matrix, you will see that the cost for traveling from A to B is 4, cost for traveling from B to C is 6, cost for traveling from C to D is 8, cost for traveling from D to E is 10, and cost for traveling from E to A is 2. And now if you will add this, you will be having a value 30. Okay, so we have minimized the total cost for the salesman for moving to all the cities. So this is the numerical for solving the TSP problem. Okay, now you can solve different TSP problems using this method.